So now let's see examples 3 and 4. In example 3, we are talking about explicit formula. So we just talked about recursive. Now we are going to see a different way to do it, which should be familiar, I guess, with what we've done, if you are thinking of what we've done already. So we got a list of numbers and we want to find the 10th term. As we said, we can find the common ratio and we can keep multiplying, in which case we would be using the recursive formula. But we found a more efficient way to do it. So rather than doing this uh, recursive formula, we are going to use another one that is called explicit. And what we do is we multiply the term number 1, in this case 8. Notice we are calling that the first term of the sequence because it's kind of natural to call it that one the first. And we multiply it by the common ratio raised to the n minus 1. So if you replace this n by 1, 1 minus 1 equals 0, and any number raised to the 0 power, if the number is different from 0, will give you 1, and 1 times a1 will give you 8. So notice, remember please, that a1 is 8, a2 is 12, a with a little 3 is 18, a with a little 4 is 27, and so on. So in this particular case, we just we know that the first term is 8, the common ratio is 3 halves because we found it dividing 12 by 8 or 18 by 12. You can do that on your calculator very easily. So 12 divided by 8. So right here we can do 12 divided by 8. And you're going to get your answer as a fraction or as a decimal. This is 3 halves. So I want you to notice how this answer is always the same when you divide one term by the term before. So if you were to do 18 divided by 12, still you're gonna get the same answer. So 18 divided by 12, so if this number is 12 and this number is 18, you still get the same answer. So that is what is called common ratio, and that's how you find it. So you know that you're gonna multiply the first term, 8, times 3 halves raised to the 9th power. So please notice that you're finding the 10th term when you replace n by 10, so the exponent now becomes 1 less, right? Because you're subtracting 1, right? So that means that this is the answer, and that you can find it from the calculator. I won't do it so that the video is too long, but please use the scientific Desmos calculator, and you will, if you just type in exactly 8 as it is times 3 halves to the 9th, so 8. I said I wasn't gonna do it, but so you said fraction, this is 3 and this is 2, and then you get out of the parentheses, and we got right here, I want you to notice raised to the 9th power, so to the 9th power, and that should be the answer that you see right here. Okay, so you found that answer. So the 10th term in the sequence is that number. All right, so I just want you to notice that the exponent is 9 because you are replacing the n by 10, and 10 minus 1 equals 9, right? So with that in mind, please try to copy down this in your notebook, pause the video. It's giving you the recursive formula, so hopefully from there, this will tell you what number is first, and from here, you will know what the common ratio is. So after a while, please check what you did and see if you got it right. You are to find the 12th term, and that should be your answer. Did you get it right? I wonder. All right, so our last example is like, not that one, sorry. Is our example 4. So here it is. So what is the connection between geometric sequences and exponential functions? So imagine that you have like, there is this class blog that has 5 subscribers and it doubles each week. So how can we describe this by using an exponential model? So we're gonna use both the exponential functions per se and also the geometric sequences. Okay, so I want you guys relating those two. Geometric sequence means exponential function or exponential relationship. So if we were thinking exponential functions, we know the initial number is 5 and we know we are multiplying each time by 2. So you're thinking of a sequence 5, 10, 20, 40, and so on. So we can do this here, and X is the number of weeks since the block started. Okay, so week 0 means when there is no time passed. All right, so it's just at the beginning. So when you replace X by 0, you see that you get 5. That's the initial number, right? So what is the difference with the other one? Well, the common ratio we know is 2. So the explicit formula will look like this. And you can tell that there is an n minus 1. Problem here, or the difference here, is that that n represents like the number, the position of the term. So what here is 5, over here actually n will be 6, because remember the first number we write here. Maybe we need to do it quickly here. So uh, this I'm gonna do it here. So for this one, we are thinking of 5, 10, 20, 40, sorry, 40, and so on, right? So, well, these, when we are talking about exponential functions, we said x equals 0, x equals 1, x equals 2. But for the other one, we are actually considering the same list of numbers, but we are not calling the initial term or the first, the 0 term, but the first term, right? So, and the second term is 10, and the third term is 20, and the fourth term is 40, and so on. So it is just shifted one to the right. So that's why if you want to find something here, we'll have to use like, we'll have to take that into account. Okay, so the number of subscribers changes by a constant ratio. So exponential function, a geometric sequence, can model the situation, only that here you will have like a different form for the exponent, but you can still use both. And with that in mind, let's go to the, well, first, let's try to erase this here. So I'm asking you to please write it down in your notebook, as always. Pause the video, and after a while, please check if you found it, if you did it correctly, okay? So the correct answer is 2560. Please try to play with exponents and see how you can get it from both models by switching that exponent. All right, so that is it. Now we are ready to practice.